So we've done solving the polynomial equations. Do you remember last time finding all the zeros? Remember the relay game we did? You found all the zeros and your classwork was finding all the zeros. We're going to do that in reverse. So you're going to be given the zeros and you're going to write the equation. This is how I make up the problems for you, by the way. Those problems that I gave you last time, this is how I create them. I start with the answers and then I create the equation. Before we start doing any problems, though, if your zeros are irrational or complex, so let's talk about those words. Irrational means you've got a weird square root in there, like a plus and minus square root of 29. Do you get what I'm saying? If you plug square root of 29 in the calculator, it would come out to some crazy decimal. That's irrational. Complex means you have I, so something with I in it. They happen in what are called conjugate pairs. It means that there is a plus and a minus. So for example, can you give me some single digit numbers and I'll just make something up?
3.
So say we have 9 plus square root of 3. Say that's one of your zeros. Even if the problem doesn't say it, that means you need to know that 9 minus square root of 3 is also a 0. Even if they don't come out and say it, you need to know that that pair is in there. And it comes from the plus minus of the square root. Okay, so you need to know that it's there. So let's make up an imaginary one. Give me some other single digit numbers. So let's say you have 4 plus 5i. Even if the problem doesn't say it, what else is a 0? Yeah, 4 minus 5i. The first section of your Delta Math classwork is literally what's the conjugate. That's it. So if it gives you 4 plus 5i, your answer is 4 minus. So the first few problems, that's literally all that you're doing. Okay. Now we may not do every single problem on here because I put a lot on here. I always put more on the notes than we really need. As a heads up, these are tedious, but not difficult. And you guys have done well with problems similar to this that we've done. So I think this is going to go okay. You just have to not fall asleep because it is a little tedious. Okay. So if one of your zeros is 0, that means your factor is just x. You can write x minus 0, but I kind of recommend against it. Now, if one of your other zeros is 6, your factor is x minus 6. And then if your other 0 is negative 2, x plus 2. Did you all get how we got there? Okay. Now you have the tedious, boring job of multiplying it all together. But if you know your multiplication tables, you're going to be just fine. Now you can only do 2 at a time. So this first one, this x, is going to just wait patiently. It is just going to sit there and wait patiently while we multiply the other ones together. X times x, x squared. Now you want to try and do the outsides and insides together to save you some work. The outsides are plus 2x. The insides are minus 6x. So what is that all together? Minus 4x, and then negative 6 times 2 is negative 12. Your last step is to distribute the x. Now, I won't make you write it on every single line, but in your final answer, you should have an f of x equals. Just throw that in your final answer to make it be officially a function, and distribute the x. It'll be x to the third minus 4x squared minus 12x. Again, that's how I made the problems for you before. I started with what I wanted your answers to be, and then I multiplied it all together, and then that was the problem I gave you. Last thing I want to connect there before we just try another one. Do you see how there are 3 zeros? And our power is 3? Okay, so you can kind of check, make sure that that makes sense. Go ahead. So when you multiply these two together, x times x is x squared. The outsides give you 2x. The insides give you minus 6x. So together that's minus 4x. And then negative 6 times 2 is negative 12. Reverse factoring. I like that. I call it FOIL, but I like reverse factoring is exactly what it is. Okay. Now, do you see how this one has a fraction? I'm just going to kind of do a little margin problem off to the side here. If you have a negative a half, your factor would be x plus a half. But nobody wants to deal with the fraction in there. So $1 million question, how do you cancel out a 1/2? Multiply by 2. So you're just going to slap a 2 in front of that and distribute it through. Hey, are we allowed to do that? Yeah. You can't put a variable in where it doesn't belong. You can't throw an X in there, but you can double things. You can multiply by a 2. You are allowed, okay? So if you distribute a 2 through there, what does that give us? 2x plus 1. Good. And see how there's not a fraction? Yay. Now the next one is 3, but it says with a multiplicity of 2. That means it's a twin. So we're going to have the factor x minus 3 twice. It says with a multiplicity of 2. So that means twice. And then you just multiply it all together. Again, you can only do 2 at a time. So the first one is going to wait patiently. You can only do 2 at a time. So the first one just waits patiently. Now let's multiply these together. That'll be x squared.
What's the first one?
Hold on a second. Minus 6x plus 9. It doesn't actually matter which one, but I have found over the years that if you hold off on the first one, everybody does better on it. So it technically doesn't matter, but I've learned it goes better that way. Yes, ma'am.
Which 2 ones you have to multiply to get negative 6x?
So your outsides are minus 3x, and then your insides are minus 3x. So together it's minus 6x. And then negative 3 times negative 3 is positive 9. Now this one was simple. We just distributed an x. Listen to me say, so some of you are like off doing the problem already, which is cool. If you want to work ahead of me, just make sure your answer's right. This is going to get really long, all right? You're going to have to take the 2x and distribute it through there. And then you're going to have to take the 1 and distribute it through there. So you're going to distribute both of them, both of them. Ready? Well, yeah, it's kind of nice that it's 1. Okay, but you still have to do it. So if you distribute 2x into this trinomial, that is going to give you 2x to the third minus 12x squared plus 18x. I just distributed a 2x into this trinomial. Now I'm going to distribute the 1, and as she just said, like that's not going to change anything, but you still have to do it. If you distribute a 1, like all that stuff is just going to stay the same. And for your final answer, you're just going to combine like terms and slap an f of x equals in front of it. So 2x cubed, and then I think we have x squareds that'll go together. How many x squareds are we going to have here? There's 2 of them, but put them together. Yeah, negative 11, good. And then plus 12x, good, plus 9. Cool. I told you it was tedious, but it's not hard, okay? And again, we might not do every single one on here. Let's do either 3 or 4. They're kind of the same type of problem. Which one do you want? 4. Okay. So if you have negative 6 as your 0, your factor is x plus 6. Now, it says that there's square root of 2, but that means you need to know that there is also negative square root of 2. They come in the plus minus pairs. They're called conjugate pairs. So one of your factors is x minus square root of 2, and even though it doesn't say it, you need to know what's the other one. X plus square root of 2. So again, like that's you having to know something. They come in the plus minus pairs. It's a good thing because it'll actually cancel out the root and it'll turn out better. All right. I'm getting there. Oh, you're ahead of me. No, I want to see that step. I need you to show me that step because it shows me the plus minus pair, and that's the concept that I'm testing you on. But you're not wrong. You're just ahead of me. Hold on a second. So when you multiply these together, x times x is x squared. Now, when you have a conjugate pair, the outsides and the insides will cancel because one is plus and one is minus. Do you see this here? The outsides give you plus x square root of 2 and the insides give you minus x square root of 2. Are you guys following me here? They're gone, which is great. Now, when you multiply the last, a negative times a positive is going to be a negative. Square root of 2 times square root of 2 is just 2. Square root of 2 times square root of 2. It would be square root of 4, which is 2. Do you get what I'm saying here? You guys are usually more talkative than this, so I'm like, is it connecting? Okay.
Oh, so you're just doing the number inside numbers.
Correct. Yeah, so for example, what is square root of 10 times square root of 10? 10, like they cancel out. All right, so this is going to be our, yeah, exactly, square root of 100, which then would be 10. So this is going to be our last step. So you can go ahead and put the f of x equals, it's going to be x cubed plus 6x squared, and then minus 2x. You see where I'm getting this from? Minus 2x, and then minus 12. Is that okay? I just wanted to pause while we let it sink in, okay?
Oh, they wouldn't combine because they're the x.
Correct. Oh, that's well said. They wouldn't combine because they have a different exponent.
So you did like the x.
If I put it in the other order, it bothers people because they want it to go in descending order. That's why I did that. It technically doesn't matter what order you put these in, though. It's up to you. Again, I've been doing this for a few minutes, and I've just learned that if I write it in the other order, everyone gets upset. So I try to keep all the campers happy, you know? Yeah, I know. All right, we'll do a couple more of these, and then we'll do the ones on the back. Because, you know, I only need to do enough for you to understand what's going on. X equals -1 with a multiplicity of 2. So what am I going to put? Good. X plus 1 and then twice. Now I have 3i. That's imaginary. You need to know it comes in the plus minus pairs. So you're going to have x minus 3i, but you're also going to have x plus 3i. Now, before I go any further, because I don't want to get to this step and have everybody be like, what on earth is going on? I is the square root of -1. The purpose of it is to get that negative underneath the square root. So let's put a little star next to this. I squared is -1. I'm going to put like a colorful box around that. That is your link between the real and the imaginary, because I is imaginary, but -1 is a real number. Anytime you see an I squared, you're going to replace it with a negative. Basically, it just means opposite, okay? Now, here's what I do when there's 4. Do you see how we have 4 of these? Oh, spoiler alert, there's going to be an x to the 4th in the answer, okay? When there's 4 of them, I do the first 2, and then I do the second 2. So I'm going to multiply them together like that. Nobody has to wait patiently, right? So when we multiply these two, that's going to give you x squared plus what? Careful, because 1 trips everybody up, so just be careful. 2x, 1 plus 1 is 2. Plus 1. 1 times 1 is 1.
Wow.
Whoa. All right, for this one, x times x is x squared. The outsides and insides cancel. That's nice, kind of the whole point. Now look, when you multiply these, -3i times +3i. I'm just going to write it off to the side. That would be -9i squared. -3 times 3 is -9. I times I is I squared. But if I squared is -1, it's plus not good. Perfect. I got you all there. Oh, you did some of that last year? Okay. All right. Now you are going to have to distribute an x squared into here. Are you following me? I'm pointing to it. You're going to distribute an x squared into there. And then you're going to distribute the 9 into there. It's going to be really, really long. How many terms long should it be? 6. Why 6? Why will it be 6 terms long? 3 times 2. All right, so if we distribute an x squared, x to the 4th plus 2x cubed plus x squared. Some of you are with me and some of you are like already done with the problem. That's fine. Just make sure your answer is right. Now, if you distribute 9, that's going to be 9x squared plus 18x plus 9. And when you write your final answer, just put an f of x in front of it. Just pick up with number 6 with us. This is being recorded. You can always go back and rewatch. Everything is always recorded. I think the only like terms we have there are the x squareds. So it's basically all going to be the exact same thing, except how many x squareds have we got? Yeah, 10x squared. Again, this is how I made your notes on the last section. I picked what I wanted the answers to be, and then I multiplied it all together, and then that's the problem I gave you. All right, we'll just try one more of these. Do you want to do 6 or 7? We'll just pick one. It doesn't matter. We'll do 7. Okay. The point of notes is not for me to fill time or torture you. The point is for you to understand the concept. We just need to do enough until you understand what's going on. All right. Yeah, go ahead.
So like,
I'm gonna write this while you're talking, if that's okay.
so for the last one we did, we got that super long equation. Like, how would we, if we were like reversing that, how would we start?
To factor it apart, synthetic division.
Okay.
So do you guys see where I got the x minus 7i, x plus 7i?
Yeah.
Then what are the other ones going to be? Good. You have to know that they come in pairs. So when there's 4 of them, which spoiler alert, there's going to be an x to the 4th in the answer. Nobody has to wait patiently. I'm going to do the first 2 and I'm going to do the second 2. And the conjugate pairs are really nice because a lot of stuff cancels. So when you multiply these, it'll be x squared. And if you want to write it off to the side, when you multiply these, it will be negative 49i squared. If you can do it in your head, you don't have to write that off to the side. I'm just doing the problem in front of a whole class of people, so I'm trying to explain where it's coming from. But what is that going to give you?
49.
Yeah, plus 49. And then when you do this one, you're going to get x squared. And then what? Plus 4. Good. 2 times 2 is 4. The negatives cancel. Now this will be our final answer, so put an f of x in front of it. You gonna make it? All right, shh. Get through this. X squared times x squared is x to the 4th. Now the outsides and insides will go together. Your outsides give you 4x squared. Your insides give you 49x squared. So what would that be together? Yeah, 53, good, x squared, plus, all right, we have to do 49 times 4. I don't know that off the top of my head, but this is fair game for pre-calc. Doing a 2-digit times a 1-digit is totally acceptable for you to have to do without a calculator. Do you remember how to do this? There's 9 times 4 is 36. 4 times 4 is 16. Add the 3. So 196 plus 49 plus 49 plus 4, valid as well. If it was 49 times 7, a little more tricky, but all right. Now looking at this one, we did skip a few. We don't need to do every single problem on here.
Oh wait, no, I didn't mean that. Like, at our answer, don't we have, you have to put zeros?
Yes, yes. Okay. So for x equals 2, your factor would be x minus 2. But what multiplicity did I put for this? 5. Now, do you want to do x minus 2 times x minus 2 times x minus 2 times x minus 2 times x minus 2? And have them all wait patiently and multiply that all together. I've got you. I'm going to show you how to do it with 2 steps. I flipped the paper over.
Oh, did we not write it?
Oh, I just wrote x minus 2 to the 5th, but I'm not going to make you do that way. I'm going to teach you a different method. Okay. So Pascal's triangle. Some of you may have seen this, some of you may have not. That's okay. I'm going to write out the first few lines and then I want to see if you can continue it. Okay, cool. Write it out that far and then I want to see if you can continue the pattern. Okay, we're going to do it again.
Yeah.
And again, we might not do every single one of these. We just need to do enough for you to understand what's going on.
Miss Colville was on the money. It made me so mad because my things would never be lined up.
Oh, all right. Well, it's okay. Now the next line, it's going to be 1, 4, 6. And then what comes next? 4, 1. How are we need to focus. How are we generating the next line? You're adding what's above it. So 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. I only want to write 2 more lines. This goes on infinitely, you know, obviously. So this would be 1 and then what? 5? 10? Good. Perfect. We'll write 1 more. You guys all with me there? All right. So I'm only going to write 1 more. 1, 6, And then what? 15.
20.
Well, 5 plus 10 is 15. 10 plus 10 is 20. And then 15, 6, 1. Now, before I start doing a problem, this is called the 0th line. It's the 0th line. That's because anything to the 0 power is 1. This is the first line. This is the second line. This is the third line. This is the fourth line. It makes sense. The fourth line is the one with the 4 in it. The fifth line is the one with the 5 in it. Do you get what I'm saying? Okay. What I want to happen for this first problem is I want you to all set your pencil down and look, and don't look away. So everyone set your pencil down. If you learned it last year and you're trying to figure it out, that's fine. I just stop for a second and look, because I don't want you to miss it. Now, do you see how this is to the 4th? You're going to take the 4th line, the one with the 4 in it, okay? Just watch me do this. Do not pick up your pencil. I will give you a chance when I'm done to write it all down. So do you see how it's 1, 4, 6, 4, 1? 1, 4, 6, 4, 1. I just left a bunch of space. Do you see that?
Yeah.
Those are your coefficients. Now you take the first thing, which in this case is just x, to that power. So x to the 4th, and then you do your count down. Do you see what I'm doing here? And I strongly suggest that you put the ones and zeros. 4, 3, 2, 1, 0. We're going to fix it in the next step. These are 2-step problems. One step, you write it all out. The second step, you simplify. All right. Then you take whatever the second thing is. In this case, it's a 2. And you do the same thing backwards. So do you see how I'm doing this here? So 0, 1, 2, 3, 4. And then you slap a bunch of plus signs in between. And then in the next step, we're going to simplify it. So go ahead and write it out. We'll wait while you write it down, and then we're going to simplify it. They are 2-step problems. It is only 2 steps. While you're writing it, I'm going to keep talking. On Delta Math, I can't control this. I will not give you a problem that is higher than a 5th power. So if it gives you one that is higher than a 5th power, I welcome you to skip it. I always get some people that are like, no, I want to try it, even though it's to the 8th. You're welcome to do that, and that's fine. But if it's higher than a 5th power, you can skip that. The way you skip is you just enter a blank answer twice, and it will mark it wrong, and then you just move on to the next one. Does that make sense to everybody? So I'm not going to make you do something to the 9th power, okay? It's a bit crazy. Oh, well, I don't know. I explain things the way I would need them explained to me, which is as though you're the village idiot. So that's how I explain it. Like, do you know what I mean? That's how I need it explained to me. Now, here's my suggestion. Anything to the 0th power, scribble out. If it's to the 0th, it's gone. But I still want you to write it because it's part of the pattern. All right. So now let's simplify it down. This first term would just be x to the 4th. Plus, now, exponents come first. PEMDAS. Exponents are first. 2 to the 1st power. 2 to the 1st power is 2. Thank you for staying focused. And then 2 times 4 is 8. So 8x cubed. Plus, exponents come first. 2 squared is 4 times 6. So 24x squared. 2 cubed. 8. Thank you so much for not saying 6. I love you. All right. 8 times 4, 32. And then 2 to the 4th is 16. You would do well to remember 2 to the 4th power is 16. 2 to the 5th power is 32. Those are just good ones to know, like to just have in your back pocket. But that's your answer. All right, let's try another one. Do you see how this is to the 3rd? Third line. So your coefficients are what? 1, 3, 3, 1. Just go ahead and write them out and leave some space. Now, do you see how the first thing is an x? You're going to start with that. So it's x to the 3rd, x to the 2nd, x to the 1st, x to the nothing. I strongly suggest you write them. I guess I'm not going to take off or have an argument with you if you don't write x to the 0, but it's part of the pattern, and I just think you should do it. You're not going to get confused as long as it's there. Now, the second thing is -4. So it is -4 to the 0, -4 to the 1st, -4 to the 2nd, negative 4 to the third. And then just slap some plus signs in between. And you're good to go. It's 2 steps. We only have one more step. You simplify it down. So anything to the 0 power, I would just scribble out. And then you're going to simplify it down. So your first term is just x cubed. Exponents first. Negative 4 to the first is negative 4 times 3 is negative 12. So negative 12x squared. Negative 4 squared is 16, positive 16 times 3 is 48. Good. And then negative 4 cubed. Well, do you know 4 cubed?
64.
64, but it will be negative 64. Now, I want you to notice something about that. What's going on with your terms? The signs of them, I should clarify. Do you see how it's positive, negative, positive, negative? When you have a subtraction, that's what's going to happen. Positive, negative, positive, negative. All right, I'll do 2 more of these. Let's pick either 3 or 4. They're pretty similar. Which one do you want to try? We'll do 4. What's your power?
4.
4. So you're going to use the 4th line, the one with the 4 in it. Your coefficients are 1, 4, 6, 4, 1. This is usually where people start to work ahead of me, but be careful because there's a coefficient in this one. Do you see that 2 there? You're going to have 2x parenthesized to the 4th. Give it a hug. And then 2x to the 3rd, 2x to the 2nd, 2x to the 1st, 2x to the nothing. That is going to complicate our second step a little bit, but if you can multiply by 2, you're going to be all right. You just have to stay calm and organized. And then your other number is a negative 1. So it's negative 1 to the 0, negative 1 to the 1st, negative 1 to the 2nd, negative 1 to the 3rd, negative 1 to the 4th. Slap some plus signs in between. It looks awful, doesn't it? It's really not that bad. I look up there, I'm like, wow, that looks like it's written in Egyptian. It's like numbers everywhere. But that's why the pattern is so important, is so you don't lose track of what you're doing. So scribble out anything that's to the 0. Those are going to go away. I know it's hard. I think you're okay, though. Are we ready to simplify, or?
Yeah.
I don't want to leave you behind.
Yeah.
Well, that's why I do all the x's first. All right, this first one, 2 to the 4th. Good, 16. So it's 16x to the 4th. Now watch me do this one. I usually just write it right above. You have a 4. 2 cubed is 8. And negative 1 to the 1st is negative 1. I just write them right above that. Multiply those together. What do you get? Good. Negative 32 x cubed. Just write it right above there. Little notes to yourself. All right. So this one, you've got a 6. 2 squared is 4. And negative 1 squared is 1. So then multiply those together. So 24x squared. See, it's not that bad, right? It's just you have to stay organized. I know, it all of a sudden like kicked on the AC. All right, this one, 4. 2 to the 1st is 2. Negative 1 to the 3rd is negative 1. And then multiply those together. Negative 8. And then this one, negative 1 to the 4th is just 1. And do you notice it goes positive, negative, positive, negative? Positive. All right. We'll do one more because this one has a y in it, just so you can see it. Ooh, also, this is the only one I did to the 5th. You're going to use the 5th line, the one with the 5 in it. 1, 5, 10, 10, 5, 1. I'm going to run out of space. So those of you that did this last year, is it coming back to you a little bit? Or is it making sense?
Yeah.
If you're seeing it for the first time, are you? You hate it. Well, would you rather do 2x plus y times 2x plus y times 2x plus y times 2x plus y times 2x plus y? No. Yeah, okay. So look, I think this is what you got you on the last one. Can you write it the way I do? 2x to the fifth, and then do 2x to the fourth, and then 2x to the third. Like go through and do all of those first. Go through and do all of those, and then go through and do y, and it's going to go opposite. So what am I going to start with in the first one? Y to the what? Oh, I'm waiting. I'm sorry. I know. I'm sorry. I did too because of the hole in the paper. I would have been fine if that hole wasn't there. All right, so it's y to the nothing, and then y to the first, y to the second, y to the third, y to the fourth, y to the fifth. Slap some plus signs in between everything.
To do my one.
When we simplify it, it'll get smaller. All right. So scribble out the stuff that's to the 0. And here we go. This won't be as bad as you're thinking. 2 to the fifth. 32. Again, you would do well to know 2 to the fourth is 16 and 2 to the fifth is 32. So 32x to the fifth. Now write right above it. Just a little note to yourself. We have 5. And then 2 to the fourth is 16. 5 times 16. You can either count by 16s. You can do a little problem off to the side. You can do it in your head. However you want to get through that, it's 80. Okay? It's 80. And then what are your variables? X to the fourth, y. X4, y. Plus. All right, let's do this one. 10. And then 2 cubed is 8. So again, it's 80. And then your variables. You okay? Oh, 2. Good. Perfect. Shh. Couple more. Hang in there. You're okay. There. It sounds like you got it. All right. 2 squared is 4. So 40 x squared y to the third. This one would just be 10. 2 to the first is 2 times 5 is 10 x y to the fourth. And then the last one is just y to the fifth.